Hello and welcome back to the channel. This video is the third and final installment of the spin indexer build. Now if you haven't seen my other two videos, I'll leave the links in the description. In this video we'll be making the indexing plate and a mechanism to be able to index the holes with a pin at the back here. Now, unlike the spin indexes that you can get from eBay and those other places, you know, the cheaper ones, they have their indexing wheel at the front here. Whereas in this case, we're going to put it at the back here. A lot of people have complained about the Chinese ones with them in the front, and they don't have a lot of room to work up the front here because the big disc is in the way here. So we're going to put it at the back, and that will give us plenty of room at the front here. So I made this indexing plate for my lathe, but the one we're going to make for here will be similar, and the one that, you know, traditional spin indexers come with, well, the factory ones, have 36 holes in them. So there's 36 holes in the plate, so they're 10 degrees apart, and then there's a sort of a vernier scale at the back here where you can actually do 1 degree increments, so it's 360 different positions in rotation. Now that's going to go onto the spindle here at the back, and I'll just slide this forward a bit. So it'll look something like that, and of course then you'll have your vernier up here with the pin that can go through into the hole. And on this indexing plate, I've used 1/8 holes here. That's like 3 millimeters. So I'm gonna be using a bigger hole, maybe a 1/4 inch hole or a 6 millimeter hole for the indexing plate that we make for this one here. Now the plate's not going to be attached directly to the spindle, so I'll have something a little bit like what I did on this one. Well, I'll have some sort of, I guess, boss or arbor, I don't know if they're the right words, but that will go onto the spindle and be locked onto the spindle, and then the plate will be bolted onto that boss, and that's how that will fit on. And that allows me to make different plates for different purposes, so I'm not sort of just stuck with one plate and the attachment all in one, so it's going to be separate parts. So that's going to give me a lot more flexibility to add different plates if I need them in the future. So the first thing I needed to do was work out what size indexing plate I needed, and to work out how much clearance I need around the rear dust cover here. I found it better to sort of draw this out in full scale, so I've got a good idea on the size and what size indexing holes I needed. Now I started making the bracket that would hold the vernier scale, and in hindsight this is probably the last thing that I should have made. And that fly cutter wasn't going any good, so I used the boring bar instead here. Now while I check the size here, have a look at that boring bar tool. It's pointing up, and I did bore it from the bottom upwards. I don't know why, but these boring bars seem to be left-handed when you put them in the boring tool this way. And the reason why I should have made this plate last is because I made a muck up here. I actually drilled and slotted these holes, and they didn't really need to be slotted at all. So that part was a throwaway, and I'll make that part again later in the video. Well, I don't actually show it in the video, but basically it's the same process. I cut it off here and I clean up the top with the mill. So that gets welded to the housing in a couple of places there. And then of course the vernier scale is made up of a lot thicker steel and is bolted on to where those holes are. So now I'm making the locating ring for the indexing plate, and I'm using some of this AISI 52-100 steel. That's kind of hard. The disc doesn't go right through, so I have to give it some encouragement to come off there. Cleaning up the end, and of course we'll put a centre in there as well. And then I'm just cleaning up the face there. And this is the locating ring, so the indexing plate will sit on this ring, so this ring has to be exact size, pretty precision. And now I drill and bore out the centre to the size of the spindle shaft. This needs to be held in a collet chuck for alignment and then mill. So I'm going to put a arbor or a bit of steel in the end here. So it starts 25mm, cut a piece off, and then we turn down to the right size that will press fit into that hole that we saw on the other part on the bench. And we just turn down the rest of it so that that can fit nicely into our collet. And then I put a bit of oil on there and press that into the locating ring for the indexing plate. And I'll just chop off the end there that wasn't machined. We don't need that anymore. Now I'm making the indexing plate, and I'm just using a bit of 6mm or 1/4 inch steel plate here. And I'm just cutting out a square. It's a square so that I can hold it in the forge or chuck easily. Then we find the centre and we punch that, and then we use a centre drill just to make a centre in there so I can put it in the lathe and dial it in. Now this is probably another mistake. I couldn't really get a good clean finish on here. I think the part is so big that I had to change speeds 3 or 4 times to try and get that done. And again we're drilling and boring out the centre to the size that we need to fit onto this locating ring. And that fits on perfect. Now I use that in the mill to find the centre so that I can drill the holes around the indexing plate. A little bit shaky on the shot. But basically I just go round 10 degrees at a time and I'm just drilling centre holes at this point. This is where things went a little bit pear-shaped. Now this should fit into the last hole, and it doesn't. So something happened and I wasn't aware of it, which I'll talk a bit more about later. So at this point I just carried on. I drilled the holes out. Went through with a 8mm reamer. And then I just sort of countersunk all the holes. And on my way back to the workbench, I walked past the mill and I saw this. That Y should be on 0. Then I mounted it up in the lathe just to check it, and as you can see there, it's wobbly. Here's a couple of close-ups. So you can see on the left the line is pretty much touching the indexing holes, and on the right, you know, there's a millimetre or so that's off there. And there's the fist of rage. So I had to start again, and we'll really fast forward through this part because you've seen it already. Is it going to fit? So same process, drill the holes out, go through and ream the holes, and then just take the edge off. Then I start cutting out the plate so it's kind of in a round circle the best I can with the grinder. And then I mount it up onto our locating ring. I've threaded a bolt in there so I can lock it in place. And it's just pretty much taking the outside off. And I didn't even bother with facing the front and the back this time. I just left them as they were. Now we're just cutting the locating ring off the arbor bit that we had made. Cleaning it up in the lathe there. And that fits on there beautifully. So now I'm just taking some measurements for the vernier scale. That's the part we'll make next. I'm using a bit of 16mm flat bar here. Actually, I use 2 pieces. And I weld those pieces together. I'm up to the vernier scale now, and this is a little bit tricky, but I'll try and describe it the best I can. So just starting with a piece of steel, I just used 2 bits of 16mm thick steel here, and I needed to use 2 pieces because I need to have a pivot point which is actually on a separate piece, so I didn't have a piece wide enough for this. So I've just sort of tacked these together for now. That's our pivot point. There'll be a hole drilled in here, and that's how I'll line up the center of the mill spindle. Then we measure out our 68mm to match our indexing plate that we've already made with the holes, and that's where it'll pivot around that radius there. So I'll put that to the side, and then I'll talk about these holes. And this took a little bit of working out, and I think I understand it. The holes here in the indexing plate are 10 degrees apart. 36 holes, 1 complete circle. However, the vernier scale is 11 degrees apart. So basically you have a 0, 11 degrees, 22, 33, 44, etc. all the way through. And that's so that it moves 1 degree increments, and that sort of gives you your vernier scale, if that makes sense. Now, I've watched a few videos on these spin indexes and the way people describe them and how they show setting up the vernier scale and how that works. And what's important that I see here is that this center line at the top, which is your marker that you would have indicating whereabouts the hole is. So if it's you know, the 20 degrees hole, and that's at the top on that mark, then that's 20 degrees. But that's important to be right in the middle here of the vernier scale at 49.5 degrees. So it's 49.5 degrees this way, and 49.5 degrees up to the number 9 here this way. And I've put an extra 11 degrees at the end here back to 0. And that just gives me a reference here to line up the holes here. So that hole and this hole will line up. And also right in the middle here of 4 and 5 will line up as well with a hole. So if we overlay the plate onto this drawing, so I hope that comes out on the camera good enough for you guys to see. But as you can see at the 0 here, we're right on the cross as you would expect, because that's where you'd line up the first hole. And of course when we get past the 9 to this 0 here, and those indexes that you buy off Amazon, they don't actually have a number 0 here, they finish at 9. But I've just put this here for a reference, and I'll probably machine this into the block as well, because that will give us a way to set up our vernier scale as well, so that it's accurate when we bolt it on. And then of course you can see right between the 4 and the 5 at the top here, that's exactly where we are there. So I think I have this nutted out as best as I can. So I'm going to go ahead and set up that piece of steel in the mill and drill the holes for the vernier scale. If my calculations are correct, then that should work pretty good. So these holes are being drilled 11 millimeters apart. Of course I go through and drill them out with a proper drill, ream them and use the countersink to take off the sharp edge. So I think that went pretty well there. And I've put a couple of bolts in here for the 0 positions, which would line up with the holes on the plate and underneath at the back there. So I might have to tilt this, I'm not sure how much of an angle you're going to be able to see. So basically that's the 0 positions there where the bolts have come through, they line up perfect, and then you can see the plate at the back is offset heading towards that way there, and that's 1 degree each time. So basically there are 9 holes in the plate at the back, the thick plate, and there are 10 holes here, so it's sort of offsetting by 1 degree each time. So that worked out really good, and we can move on and then cut this piece out. So I just made up a little jig so I can get the right radius there, and we use the grinder to try and shape it out as best we can. And then I just used the belt grinder to get the shape, and that came out really good. Now I just need to get a clearance on the inside radius to clear that dust cover. There's no easy way to cut this out, so I put it back in the mill, wind it up again, and I just used an end mill to chop all the way through 16 millimeters, which did take a little while. And then we cut that piece off, and that's pretty much done. Now I'm just milling a flat on the spindle shaft, and that's for the locating ring for the indexing plate to lock into one position, and also the handle that you can spin the spindle with. Now I'm working on that locating ring again, and we're drilling and tapping a M8 hole here for a locking screw. Then I need to mount the indexing plate to this locating ring. And I like to drill and tap one hole and then screw that in and then come back and do the second hole. And that way I know that everything is all lined up perfectly. Just doing a quick fit up here. As I mentioned before, I had to remake this bracket that gets welded to the body of the spin indexer. I'm just marking out where the holes go. And we drill and tap those holes into the vernier scale. And then I cut that piece off and get it into the shape that I need, and then I bolt everything together, line everything up and weld that bracket onto the body. Now I'm making the indexing pin, and I think this is a bit of 16mm round bar. I'm knurling the end there so that you have got good grip when you pull the pin out and put it in. And then I take the shaft down to the final dimension And just a little bit of a clean up with the radius tool there. Then cut it off. And that gets tested out. And you can see here as I push it in, the vernier scale, it sort of moves round to where it needs to go. So that all works nicely. Now I'm reusing that bit we cut off the locating ring, and I'm going to make the handle for the spinning indexer out of this piece. I just need to bore out the inside a bit more there and take the outside down, and then we part that off as well. This is a smaller piece, so I'm drilling and tapping for a M6 locking screw. This piece gets welded onto that ring, and the handle gets screwed in the end of this piece. It'll become a bit more clear a little bit later. Again, that's an M6 thread. And I sort of cut some angles here to give it some shape. To be honest, I really did spend too much time on this handle part for the spinning indexer. That's welded on there. And then I'm making the handle that you hold while you're turning, and I'm cutting a 5-degree taper on here just for aesthetics. We need a 6mm or 1/4 inch hole down the centre, and this is a 10mm hole to clear the bolt screw head. I actually go in there with a 10mm end mill just to square up the bottom of the hole as well. And then we part that off. Just doing a bit of fit up. And that all works perfect. Now we need to stamp the indexing plate and the vernier scale. I'm writing the degrees on the indexing plate here. I don't want to make any mistakes on this part because I don't want to remake this again for the 3rd time. I made this jig for stamping. I got the idea from a video that Mr. Pete did, and I'll put the link in the description. So he had to stamp some dials that he made, I think for his lathe, but it was a really good idea, so I sort of used that idea and adapted it on this jig as well. At the moment I'm doing the 2 digits, so there's this one shim that I use on the left and then on the right. And then we move into 3 digits, so that's the left digit. In the centre I put 2 smaller shims there, and on the right hand side that number has the same as the first one, but the shim is obviously on the other side. Always have a good look at that before you move on. And that's basically the numbering done, and that came out really good. I was quite surprised. So how the vernier scale works, if you want to get, say, 24 degrees, you just move to the 20, put the pin in the 4, move it across a little bit, and that would be 24 degrees. And here I am stamping the vernier scale. Didn't have to really make up a jig, I just sort of spaced it out. And this got the numbers practically in the middle of the vernier scale, which was good. And that's the pretty much finished product mounted on the mill. Well, that's the Spin Indexer project complete. Although it's kind of a simple piece of machinery, there's a few new things I needed to do here, like the numbering, making up jigs for that. So just to recap on the differences from the standard ones that you buy on Amazon, I'll put the indexing plate at the back. On those ones from Amazon, they're at the front here, and they're kind of very close to the 5C collet that you have. So it's hard to get in there close, with your milling spindle. So that was put on the back there. The vernier is not fixed to the body permanently. So that vernier is designed for this indexing plate. If I wanted to make, say, a 100-hole indexing plate, that would be a lot bigger. And of course, I'd make a vernier to suit that, and that would bolt on here as well. I've made the height quite a bit higher than the standard one as well. So if I do go into larger plates, I've got plenty of room at the bottom here without hitting the table of the mill. I blued most of these parts at the back here, the disc. It didn't come up fantastic, although I blued it with cold blue, and of course that went into where the numbers are, and then I spun it up in the lathe and just used a bit of, I think it was about 320 grit sandpaper just to shine it up again, and that really makes the numbers stand out with great contrast. The numbers on the vernier, you can see them, there's no problem there. I didn't punch them as hard as the numbers that I punched onto the disc, and that's because I didn't really have a jig and I didn't want the punch flying off at a weird angle. So they are able to be seen there, and the same thing, I just blued this vernier piece of steel, and then I took it over to the belt grinder with a fine grit and just skimmed the top here. So the numbers, again, there's a bit of contrast there for them to stand out. So that pretty much concludes the build. If you do like my videos, click on the subscribe button. And if you want to be notified when I create new videos, click on the bell button. I hope everyone has a great day. I know many of you are wondering, what's with the bolt? Well, this is one of those pranks that you can play on the new apprentice. You call them into your office and hand them the bolt and ask them to go and find a spanner in the workshop that fits the bolt. You can just imagine them out there. Thanks for watching.